Hi, I'm Rob, and I'd like to welcome you to this AWS Purpose-built AI Services video in the AI on AWS playlist on the Cumulus Cycles channel. AWS offers a wide range of AI services designed to solve specific tasks out of the box. These are not general machine learning platforms. They're purpose-built services that you can integrate directly into your application without building or training models from scratch. In this video, we'll explore these services and see how they can add intelligence to your applications. We'll focus on pre-trained, fully managed capabilities, such as Amazon Transcribe, which converts spoken audio into written text. It allows applications to understand human speech from sources like calls, meetings, or videos, making audio searchable, analyzable, and accessible. Amazon Polly, which turns text into natural-sounding speech, enabling applications to speak to users using lifelike voices, improving accessibility, and enhancing user experience across devices. Amazon Translate automatically translates text between languages, helping applications break language barriers by enabling real-time or batch translation at global scale. And Amazon Comprehend, which analyzes text to detect sentiment, key phrases, entities, and language. It allows applications to understand the meaning and context of unstructured text without building custom NLP models. We'll also look at Amazon Rekognition, which analyzes images and videos to identify objects, people, text, and activities. It allows applications to gain visual understanding from photos and video streams without building custom computer vision models. And Amazon Textract, which extracts text and structured data from documents. It goes beyond basic optical character recognition by identifying forms, tables, and key value pairs, turning documents into usable, actionable data. And there's also Amazon Lex. However, I won't be covering Lex in this series because I have a dedicated playlist for it, which I'll include a link to in the description below. We'll not only look at these services in the AWS console, which I think is a good learning tool, we'll integrate them into custom applications, using them to solve common business problems efficiently. So instead of building models from scratch, we'll call APIs and get results immediately, letting us focus on application logic, integration, and end user value. Now, with all that out of the way, let's get started and see these purpose-built AI services in action. Before we jump into the AWS console to take a look at the services, I want to mention that I'll place a link to my GitHub repo for the videos in the playlist in the description below. In this video, we'll be looking at the content in the 0_purpose-built AI services folder, which has several markdown files with short descriptions of the services, along with snippets of code to call the APIs. After we look at the services in the console, we'll shift our attention to the demo folder, which has a Jupyter notebook that we'll use to actually make the API calls and see the results. So, although we're going to jump into the console now, there's some cool stuff coming along, so just bear with me if the console's not your thing. Okay, so here we are in the Amazon Transcribe AWS console. Let's go ahead and click on Create a Transcript. And since Transcribe creates a transcription of an audio stream, I'll go ahead and click the Start Streaming button and then play an audio recording. And as the recording's playing, we should see the text show up in the transcription output. So let's give it a shot.
Welcome to our automated customer service system. Your call is important to us. If you need to file a new insurance claim, please press 1. For questions about an existing claim, press 2.
All right, so that looked pretty good. Scrolling down, we see a couple sections we can expand. The first is language settings, which the default is specifying a specific language, which defaults to English. But if you know your audio is in a different language, you could go ahead and select that here. You can choose automatic language identification, and if there are multiple languages, you can select this option. One other selection I want to point up is under content removal settings, where you can select vocabulary filtering and PII identification and redaction. Moving over to Amazon Polly, we'll click the Try Polly button. And since Polly is a text-to-speech service, we'll provide our text here and then click the Listen button.
Hi, I'm Ruth. I can read any text for you. Test it out.
Okay, so that's the default language of English with the female Ruth voice. We're using the generative engine to produce the most expressive and adaptive speech, but choose one of these other options if they make sense for you. Now I'm going to replace the default text with a sentence of my own, and let's go ahead and change the voice this time, and we'll click listen.
Hello, I need to file a claim. My name is Sarah Johnson. My policy number is AC 8,923,471.
Okay, that sounded pretty good, but obviously we had an issue with the policy number. So to correct the policy number pronunciation, we can use the SSML option, which is Amazon's speech synthesis markup language, and wrap our input text in a speak block, and specifically the policy number in a say as interpret as characters block, and an say as interpret as digits block. Now let's go ahead and listen.
Hello, I need to file a claim. My name is Sarah Johnson. My policy number is AC-8923471.
And that sounds more like we would expect for a policy number. Under the additional settings, there's a custom pronunciation option where you can create a lexicon, which you would do here by uploading a XML or PLS file, specifying the pronunciations you need for your use case. Amazon Translate provides natural and fluent language translation. So let's launch a real-time translation. For the source language, we'll let it auto-detect the language. And we'll do a translation to Spanish, since I'll be entering English text. And here we see the translation. Now let's go ahead and copy this. Go to English. Replace the source language with the Spanish version, and we see the translation. Under additional settings, we have options for custom terminology, brevity, formality, and profanity masking. Amazon Comprehend provides natural language processing, so we'll go ahead and launch Comprehend and replace the default text with our own text and analyze. Now with the analysis complete, we see that we have several entities underlined in the text with a detailed description of the entities below, as well as key phrases, the language it detected, which is 99% confident that it's English, it did find some PII, the sentiment was detected as 61% neutral, with details on targeted sentiment, and below we see the syntax. Amazon Rekognition is a deep learning-based visual analysis service. Here in the image, we see several bounding boxes with labels, so it's identified a building, a car, a person, a skateboard, and several other cars. It's 99% sure that this is in a neighborhood, a city, a road, and we see the rest. So let's give this a shot with our own image. And here it's identified that the image contains cars under transportation and vehicle, and the bounding boxes indicate a car, another car, a license plate, and a wheel. And if we look at the detailed response, we see the data it's found, as well as the locations of the bounding boxes. And Amazon Textract will extract handwriting text or data from any document using machine learning. So let's go ahead and try Textract. And here we see in the demo pay stub, it's identified several pieces of text, It's broken out the layout. It's found data in forms, tables. You can execute queries against the data, and it's found one signature. Now we'll go ahead and upload a document of our own. And we'll select the data outputs for layout, forms, and tables. Apply the configuration. And we see the results for the raw text, the layout, forms, and a table. Okay, now that we've concluded our whirlwind tour of these services in a console, let's take a look at the Jupyter Notebook and submit some API calls against the services. Now, here in Cursor, I've opened a preview of the README file in the demo folder. And of course, this is on the GitHub repository as well. So scrolling down, we see a few prereqs. The first is obviously you need to have Python installed. I'm using the UV package manager, but really you can feel free to use whichever package manager you're comfortable with. Of course, you need an AWS account and you need AWS credentials. So you'll need to have an access key and a secret access key, which you'll use to populate variables in the .env file or use AWS configure, whichever you're comfortable with. In this example, I'm using a .env file. So first, you want to create your virtual environment, which I've already created using UV. Then activate the environment and install your dependencies. And of course, we need to configure the AWS credentials in the .env file. So I have a .env example file that you can copy and save as your .env. Go ahead and populate your access key and secret access key. Set your region, which I'm using US East 1, and create an S3 bucket, which will be used by Transcribe and Rekognition, and provide your bucket name here. And in the assets folder, I provided an input.mp3 file and an input.ping file. Go ahead and upload those into your S3 bucket. If you change the names, go ahead and update these values as well. So I'm going to go ahead and update my env file off camera to provide my AWS credentials and bucket name. And now we can look at the Jupyter Notebook. But instead of looking at it in Cursor, I'm going to open a terminal. And I'm going to activate my virtual environment. And launch the notebook. All right, scrolling down, we see the prereqs and how to set the virtual environment and how to launch the notebook. So the first cell, we're going to import Boto3 since we'll be using the AWS Boto3 Python library, as well as some other dependencies. We'll load the .env file and then print the version of Boto3 which is installed. Here, we're going to use Boto3 to instantiate a session in which we'll pass our access key, secret access key, and region, print the region name, and ensure that we have our credentials configured. So let's go ahead and run the code in this cell. And we see the output and that we're using the creds from the .env file. Now, the first example is for Transcribe. So here we're going to use the Boto3 library to create a Transcribe client, setting the region name, and we'll give it a job name. Here we're setting the S3 bucket equal to the value in the env file, and the S3 key, which is pointing to the input wave file. We'll set the value of the job URI variable to the S3 bucket and key, as well as values for the output of the transcription results. We'll set the media format and then call the start transcription job on the client, passing the job name, the media file, the format, language, the output bucket, and the output key, and store the result in the response. So here we'll wait for the job to complete, and if the status is completed, we'll print our successful message, else we'll indicate a failure. Then we'll output the path to the transcription result. So let's go ahead and run the code in the cell. We see the job is started, and now it's complete. So if I jump over to the S3 bucket and go into the transcriptions folder, we see the example JSON, which we could download and then view. And here we see the transcript from our file input. Next, we'll look at an example of using Poly. So here we're going to instantiate an instance of a Boto 3 Poly client. We'll set our text and then call synthesize speech on the client, passing it the text, the output format of MP3, and the voice ID of Joanna. We'll store the result in the response and write the output stream to an output.mp3 file and then print the result that it's complete. So let's go ahead and execute this code. And over here we see the output file, and let's take a listen.
Welcome to our automated customer service system. Your call is important to us. If you need to file a new insurance claim, please press 1. For questions about an existing claim, press 2.
And that sounds pretty good. The next example is with Translate. So we'll create a Translate client, set our text, call Translate text on the client, passing the text, the source language as English, and the target language as Spanish. Then we'll print the result. So let's run this. And here we see our original text as well as the translated text. Next, we'll create a comprehend client, setting the text, and then we'll call the detect sentiment method on the client, passing the text and the language, print the sentiment and the sentiment score, as well as the entities. So let's run this and take a look at the result. Here we see the sentiment is neutral with the sentiment scores and found entities. And finally, we'll look at a Rekognition example. So we'll create the Rekognition client, set the S3 bucket and the image key, which we defined in our .env file. We'll call detect labels on the client, passing the path to the image and the max labels in min confidence. Then print the results. So we'll go ahead and run this, and we see the detected labels. So that concludes this video on AWS Purpose-built AI Services. In the next video, we'll look at a multilingual chat application which uses Amazon Translate and Comprehend to translate chat messages between English, Spanish, and French, as well as provide color-coded sentiment analysis of the message text. I hope to see you there.